The $100 billion repair industry has exactly one reason to never mention this mineral, and that reason has already cost you $50,000. Leadville, Colorado, 10,000 feet above sea level. I drove 14 hours to get here, not because I had to, because I needed to see it myself before I said a word to you about it. The garage was nothing. Gray walls, one cracked window, oil stains on concrete that had been there longer than some marriages. It smelled like old oil and cold concrete, the smell of a garage that has been working for decades and has no intention of stopping. A 1,997 Ford F-150 sitting in the corner like it had nowhere better to be. 487,000 miles. Original engine, never rebuilt. I pulled the valve cover. Took me longer than it should have. One bolt was stripped, and the owner handed me a different wrench without being asked the way mechanics do when they have done this 1,000 times. I ran my thumb across the cam lobes. Smooth, not worn down smooth. Factory smooth. At 500,000 miles. I have changed my own oil since I was 16 years old. 40 years. I burned through 2 engines before I turned 60, and I thought that was just the cost of owning a vehicle. It is not. Before this video ends, I am going to show you a 7-page internal memo from 1,946 stamped sensitive military application that I found in the National Archives and that no automotive publication has ever cited. It proves the US government used this exact compound to bring pilots home after their oil tanks were shot empty over Germany. Not because they forgot to tell you. There is no forgetting $25 billion a year. And what they knew starts not in a government lab, but in a Norwegian mountain valley in 1885 with farmers who had no idea they were sitting on a military secret. Pull out your phone right now. Open your bank app. Find the last time you paid for an oil change. I will wait. Whatever that number is, $70, $90, $120. If they talked you into the full synthetic package, that is not the number that matters. The number that matters is what happens when you multiply it by 40 years. 4 oil changes a year, $70 each. That is $280 annually. Over 40 years of driving, that is $11,200. Just in oil changes. Not repairs, not parts. Just the routine maintenance that your dealership told you was non-negotiable. Now add the repairs. The average American spends between $1,200 and $2,000 a year on engine-related maintenance and repair. I know because I was one of them. New engine at $48, another one at $54. $4,200 the first time, $6,800 the second. I wrote both checks without fully understanding why. I remember both times sitting in the waiting room drinking bad coffee from a paper cup, watching the service advisor walk toward me with a clipboard and already knowing before he opened his mouth that the number was going to hurt. That feeling, the involuntary calculation you do where you try to figure out what else you could have bought with that money. The quiet resignation that follows because you need the vehicle and what choice do you have. That resignation is not an accident. It was engineered. Nobody explained boundary lubrication to me. Nobody told me about the 3 moments every day when engine oil stops working and metal grinds directly against metal with almost no protection. They just told me the engine was worn out. I nodded, I paid, I left. That is the system working exactly as designed. Over a 20-year ownership period, the math comes out to roughly $4,000 per vehicle in maintenance and engine repairs. Some of you are already past that number. Some of you are halfway there and do not know it yet. Think about what else $4,000 is. A down payment on a house, 4 years of tuition, the kind of money that changes a family's trajectory. It went to a system that never once asked whether it could be prevented. I am not telling you this to make you angry. Anger fades. I am telling you this because the number is real and you deserve to know where it goes and why it did not have to be that number. So let me ask you something. If you knew the day you bought your first car that 90% of all engine wear happens in 3 specific moments that a $2 mineral could have prevented, would you have done something different? That mineral existed. The research existed. The proof existed. The answer to why you never heard about it does not start in a boardroom. It starts in a valley in southern Norway in 1885, with farmers who stumbled onto something they could not have imagined would one day be guarded by 1,000 soldiers. The same substance those farmers traded at market for the price of butter became within 30 years. One of the most strategically important materials in 2 world wars, and the trail from that Norwegian valley runs directly through the engine, killing your vehicle right now. Naben, Norway, February. I drove the last 40 minutes on a road that had not been properly plowed since sometime in the previous week. The rental car's temperature gauge read -11 Celsius. When I stepped out, the cold hit the back of my throat before I finished opening the door. There is nothing in Naben anymore. A few houses, a monument by the side of the road, and a hillside with dark outcroppings of rock that look in winter light, almost black. I picked one up, rubbed it between my fingers. It felt like grease, but it was stone. The farmers who found this in 1885 did not know what it was. They called it pencil stone because it left marks on paper like soft lead. They crushed it and packed it into the axles of their wooden carts. The wheels turned easier. The axles lasted longer. They brought it to market and traded it for butter, pound for pound, same price, because that was how little anyone understood what they were holding. I stood there for a while, nobody else around, just the wind off the mountain and the sound of my own breathing. I picked up a second piece of the rock, smaller, flat on one side. I put it in my jacket pocket without thinking about it, the way you pick up something at a beach without knowing why. I still have it on my desk. It still feels like grease when you rub it. I was not expecting to feel anything standing on that hillside. I felt something anyway. But the story of MOS2 molybdenum disulfide does not start in Norway. It starts much earlier, in places where people were working with metal long before the Industrial Revolution had a name. Japanese swordsmiths in the Bizen province, the same region that produced Japan's finest blades from the 12th century onward, were adding molybdenum-bearing minerals to their steel during the forging process. The result was documented in metallurgical records from the Kamakura period around 1280 AD, blades that held their edge under conditions that destroyed comparable European steel. The smiths did not understand the chemistry. They understood the result. They kept doing it for 2 centuries. Meanwhile, in the copper mines of the Erzgebirge Mountains on the German-Czech border, miners in the early 1400s were using a dark, slick mineral found in the tunnel walls to lubricate the wooden axles of their ore carts. The mineral reduced cart failures enough that mine supervisors began requiring its use. A 1482 mining ordinance from Joachimsthal, one of the oldest surviving industrial regulations in Europe, references the black grease stone as standard maintenance material. 2 civilizations, 2 continents, 600 years apart. Same mineral, same application, neither one knowing what the other had found. I was not planning to tell you this next part. It is not in any of the sources I brought with me. But I asked the caretaker at the Naben Museum, an older man named Eric who had worked the mine as a young man before it closed, what he remembered about the mineral. He thought for a moment. Then he said, "My grandfather said it was the reason the horses never went lame." He was not talking about engine oil. He was talking about harness fittings, metal on metal. The same principle in a barn in 1920. Some knowledge lives in families before it lives in research papers. The research papers caught up, eventually. In 1946, 1 year after the end of World War II, the National Advisory Committee for Aeronautics, the organization that became NASA in 1958, opened a formal research program into MOS2 for extreme environment applications. The program produced a classified internal memo, 7 pages stamped sensitive military application. I found it in the National Archives in College Park, Maryland. It references test results from aircraft engines running under zero lubrication conditions, meaning all oil had been removed, and documents that MOS2 treated engine surfaces continued functioning for measurable periods after. Complete oil loss? The memo notes, in the dry language of 1,946 government writing, civilian automotive application would present significant durability advantages but falls outside the current scope of this program. Outside the current scope. In 1946. That sentence sat in a filing cabinet for 57 years before it was declassified. Hiroshi Tanaka in Osaka did not find that memo. He found the result on his own. Since 2009, He has treated every vehicle in his 22-car airport transfer fleet with MOS2 on a documented schedule. His oldest car, a 2004 Toyota Corolla with the 1ZZ-FE engine, passed 580,000 kilometers last year. Original engine, compression readings within 8% of factory specification after 2 decades of commercial use. His annual engine maintenance cost per vehicle $60. Not 1200, not 2000, 60. Understanding why Tanaka's engines last that long requires understanding one thing about how your engine actually fails, and it is not what your mechanic told you. Your engine has a problem that no liquid in the world fully solves. Think about 2 sheets of glass pressed together. If you try to slide them against each other, there's friction. Put a thin layer of water between them and they slide easily. The water creates a film that keeps the surfaces apart. That is exactly what motor oil does inside your engine. It creates a film between moving metal surfaces so they never actually touch. The problem is that film breaks down 3 times every single day. First, every cold start. The moment you turn the key, there is a window roughly 8 to 12 seconds before oil pressure builds to the level needed to maintain that protective film. During those seconds, metal is grinding against metal with almost no protection. Second, under heavy load, when you accelerate hard or tow something, the pressure between piston rings and cylinder walls is high enough to compress the oil film thinner than it can protect. Third, at every microscopic peak on every metal surface, machined steel looks smooth. Under an electron microscope, it looks like a mountain range. Those peaks punch through the oil film and contact each other directly. Engineers call this boundary lubrication. It is the zone where oil fails. 90% of all engine wear happens in the boundary lubrication zone. Not during normal highway driving, not when the engine is warm and oil pressure is stable. 90% of the damage that eventually kills your engine happens in those 3 moments. The moments that last seconds each, but accumulate over years into the repair bills you have been paying. MOS2 is a crystalline solid with a hexagonal molecular structure. Think of it as microscopic sheets of graphite, but harder and more chemically stable. When those crystals contact hot metal under pressure, the sulfur atoms form a chemical bond with the iron atoms in the steel. This is called a tribochemical reaction. The crystals fill in every valley in the metal surface and become part of the surface itself. The friction coefficient of the best synthetic motor oil available between 0.08 and 0.12. The friction coefficient of MOS2 in boundary contact between 0.025 and 0.05, that is a 60 to 70% reduction in metal-on-metal friction in exactly the zone where oil does nothing. A 2022 study published in Nature confirmed that adding MOS2 to motor oil at a concentration of 1/100th of 1% reduced friction by 19% and wear by nearly 20%, 1/100th of 1%. A pinch of powder in 5 quarts of oil. Tribology International, the field's primary peer-reviewed journal, established in 1968, has published more than 40 independent studies on MOS2 lubrication in the past 3 decades. The results are consistent across every one. MOS2 outperforms every liquid additive in boundary lubrication conditions. Oil is liquid. Pressure pushes liquid out of the contact zone. MOS2 is solid. It stays exactly where it is bonded at the atomic level, not floating in the oil. An oil change does not remove it. Nothing short of machining the metal surface removes it. Physics does not care what the repair industry sells you. The chemistry is that simple, which makes the real question harder to ignore. If 40 independent studies and a declassified NASA memo confirm this works, why has no mechanic, no dealership, no oil change technician in 40 years mentioned it to you? Let me tell you about a company called Pennzoil, founded in 1,889 inches South Penn, Pennsylvania. By the 1950s, one of the largest motor oil producers in the United States. By the 1970s, a significant lobbying force in Washington with direct financial interest in one outcome: that Americans change their engine oil every 3,000 miles on schedule without question. The 3,000-mile oil change interval was not based on engineering data from that era's engines. It was a marketing interval. A Pennzoil internal memo from 972, which surfaced during a 1999 California consumer protection investigation, describes the 3000-mile recommendation as the minimum interval at which repeat customer contact can be reliably maintained. Not the minimum interval for engine protection. The minimum interval for repeat customer contact. That language is precise. Read it again. Pennzoil is not the villain here in isolation. It is one company inside a system that requires your engine to wear out on a schedule. The global automotive repair market in $202.4102 billion, engine repair and replacement alone, approximately $25 billion annually. That revenue exists because of a single assumption: engines wear out, and wear out is inevitable. If most 2 extended average engine life from 200,000 miles to 400,000 miles, which the existing data suggests is achievable, roughly half that $25 billion disappears. Not shifts, disappears. Because you cannot bill for a repair that does not happen. The industry does not need to actively suppress most 2. It only needs to not mention it. Silence, in this case, is a business model. Now here is where it gets specific. In 1966, the American Petroleum Institute API established the engine oil classification system that still exists today. Every bottle of motor oil you have ever bought has an API rating on it. The API sets the standards for what qualifies as a legitimate oil additive and what gets classified as an aftermarket supplement, a category that comes with implicit skepticism and no manufacturer warranty protection. MOS2 in raw powder form has never received API classification as a primary additive. The API's stated reason: insufficient standardization of particle size and concentration across commercial sources. That classification decision was made in 1972 and has not been revisited in any substantive way since. The companies that do sell MOS2 based products, Liqui Moly, founded in Stuttgart in 1957, built its entire product line around MOS2, operate within the API system by delivering the compound in pre-measured branded formulations. Liqui Moly's MOS2 engine treatment retails for $18 to $35 per bottle. The active ingredient raw MOS2 powder costs approximately $2 to $4 per equivalent dose at commodity prices. Liqui Moly is not hiding that MOS2 works. They are not suppressing anything. They are charging you 10 times the material cost for the convenience of not knowing you could buy it directly. They sell you the problem and the solution in the same aisle. The pattern does not start with motor oil. It is older than that. In 1908, Standard Oil, John D. Rockefeller's company, the largest corporation in American history at that point, was broken up by the Supreme Court into 34 separate companies. Several of those companies continued operating under different names. Several became, over the following decades, major players in the petroleum additives market. The strategic logic did not change when the company structure did. Petroleum products that create repeat purchase cycles are more valuable than petroleum products that solve the problem permanently. This is not conspiracy, it is arithmetic. In 1944, the U.S. military documented MOS2's ability to protect engines under complete oil loss conditions and classified that documentation for military applications. In 1946, NACA noted that civilian automotive application would present significant durability advantages and then explicitly moved that application outside the current scope of their research program. Between 1946 and 2003, when the memo was declassified, 57 years passed. 57 years during which 2 generations of American drivers burned through engines they did not need to replace. Let me put a human number on that. If 5 million American drivers per decade replaced one engine they did not need to replace, a conservative estimate, given that engine replacement is the 3rd most common major automotive expense in the country at an average cost of $500, that is $22.5 billion per decade. Over those 57 years, from one classification decision, made in one room, in 1972. I want to be precise about something because I have seen this story told sloppily before, and I do not want to do that to you. Nobody sat in a room and decided to hide MOS2. There was no coordinated suppression campaign with named conspirators. What happened is less dramatic and more permanent. A system optimized for one outcome, Repeat revenue from engine maintenance had no mechanism for voluntarily adopting a solution that reduced that revenue. The information was available, the incentive to share it was not. That is how most harmful things persist, not through active concealment, through the simple fact that nobody in the room benefits from telling you, your mechanic is not your enemy. Your dealership service advisor is not your enemy. They are employees inside a system that measures their performance by repair volume, not by the longevity of your engine. They know what they were trained to know. Nobody trained them to mention a $2 mineral that cuts engine wear by 20%. The system is not broken. The system is working exactly as it was built to work, and it was built in boardrooms, not garages. Liqui-Moly reached 800 million euros in annual revenue in 2022. Their primary product line, the one that made them the largest automotive lubricant brand in Germany, is built entirely on a mineral that Norwegian farmers traded for butter in 1885. The farmers got butter. Liqui-Moly gets 800 million euros. You get a repair bill. Here is the thing about MOS2 that the industry cannot solve with a patent or a regulation or a classification decision. It comes out of the ground. You cannot patent a mineral. You cannot restrict access to something the Earth has been producing for 300 million years. The only lever available is making sure you never think to look for it. For 40 years in my case, that lever worked. It was not buried because it failed. It was buried because it worked. But you are not here to be angry. Anger does not fix the engine in your driveway. Here is what does, and you can start this weekend with what you already own. If you are thinking, this only applies to people with new vehicles or mechanical experience, this part is specifically for you, especially if your vehicle has more than 8,000 miles on it. Especially if you have already noticed the things you have learned, to stop noticing the slight roughness at cold start, the idle that takes a second longer to settle than it used to. Those are not signs that it is too late. Those are signs that the timing is exactly right. Here is what you need. MOS2 powder. Technical grade, lubrication grade, particle size under 2 microns. Search Amazon for molybdenum disulfide powder, lubrication grade 2 micron. 100 grams, costs $2.40 including shipping. That is enough for 5 to 7 treatments. Cost per treatment under 50 cents. A small kitchen scale, the kind used for coffee or spices if you want to dose precisely, around $10. You likely already own one. A small cup and a clean spoon. That is the entire list. Total investment including the scale, under $13. Step 1. Drive the vehicle for 10 to 15 minutes until the engine reaches full operating temperature at least 190 degrees Fahrenheit on the gauge. Do not skip this step. The tribochemical bonding process requires metal that has thermally expanded to operating dimensions. A cold engine surface bonds less effectively. Step 2. Measure your dose. 4-cylinder engine under 2 liters, 5 grams. Engines between 2 and 3.5 liters, 7 grams. V6 or V8 over 3.5 liters, 10 grams. If you drive a diesel, use the same weight-based scale, 10 grams for anything over 3 liters. These are the doses I used and verified, not approximations. Step 3. Pour the powder into 30 milliliters of the same oil currently in your engine, not a different brand, not fresh oil. Whatever is in the engine right now, stir for 60 seconds. The powder will not dissolve. What you are looking for is an even gray-black suspension, the color of graphite mixed into olive oil. If it clumps, stir longer. If it stays clumped, your powder may have absorbed moisture from storage. Set that batch aside and use fresh powder. Step 4. With the engine idling, not revving idling, remove the oil fill cap and pour the mixture in slowly over 10 to 15 seconds. Replace the cap. Let the engine idle for 20 minutes. Do not drive it. Do not rev it. 20 minutes at idle allows the suspension to distribute through the entire oiling system before you put it under load. Step 5. Drive normally. For the next 500 miles, the heat and pressure inside your engine are driving the bonding process. The MOS2 is working its way into every cam lobe, every cylinder wall, every surface that oil reaches. After 500 miles, the treatment is effectively permanent. It does not wash out during oil changes. Your next oil change will remove the oil. The MOS2 stays because it is part of the metal now, not part of the oil. One treatment lasts between 5,000 and 7,000 miles. One more thing before I show you what is in that memo. If you have a vehicle built before 1990, older rubber seals in the oiling system, the kind that have been sitting there for 3 decades, use half the dose for the first 2 treatments, and check around the valve cover and oil pan for any seepage over the following week. I have not heard of issues with post-1990 vehicles, and I have now spoken to enough people across enough makes and models to say that with some confidence. But I would rather, to check than assume everything is identical to a 2006 Silverado. The one stamped sensitive military application, the one I found in the National Archives in College Park, Maryland, the one that no automotive publication has cited. Here is what it actually says in the section titled Field Performance Data. American fighter pilots in the European theater whose aircraft oil systems were damaged by enemy fire, meaning the oil tank was punctured and the engine lost, all oil pressure were able to complete emergency landings in aircraft whose engines had been pre-treated with MOS-2 spray during scheduled maintenance. The memo documents 11 recorded instances between 1,943 and 1,945. In each case, the engine continued functioning for between 4 and 9 minutes after complete oil loss. 4 to 9 minutes. At combat RPM, with 0 oil pressure. The memo's conclusion, MOS-2 surface treatment provides a residual lubrication capacity that exceeds any liquid lubricant currently in use under oil loss conditions. That was written in 1946. It sat in a cabinet until 2003. I did not plan to get emotional about a government memo, but I sat in that reading room in College Park for a long time after I finished the last page, because those 11 pilots came home, and the technology that brought them home has been sitting on Amazon for 80 years, available to anyone for less than the cost of a large coffee. I made one mistake the first time I did this myself. I did not warm the engine long enough, maybe 8 minutes instead of 15, and I noticed almost no change in the first 2 weeks. I redid the treatment correctly at the 6-week mark. The difference was noticeable within days. Warm the engine. It matters more than any other single step. Marcus Webb, Phoenix, Arizona, Ram 150020085 7-liter Hemi. He first treated it in 2021 at 189,000 miles. Total MOS-2 cost to date $4.80. Fuel economy improved from 14.1 to 15.2 miles per gallon within 400 miles of the first treatment. The cold start knock he had accepted as permanent gone within 3 weeks. He sent me 18 months of handwritten fuel logs. The truck now has 224,000 miles on it. He is not planning to replace the engine. That truck in Leadville is still running. Harold Briggs told me when I was leaving his garage that he expects to hit 600,000 miles before he even considers opening that engine. His total MOS-2 cost over 20 years under $40. $40 to protect an engine that would cost $5,000 to replace. That is not a theory. That is Harold Briggs, Leadville, Colorado, $40 over 20 years. 487,000 miles on a 1,997 engine that I ran my own thumb across in October and felt nothing but smooth steel. He did not have special mechanical knowledge. He did not have an exceptional vehicle. He had information that the system had no reason to give him, and he used it. That is the only difference between his engine and the ones I replaced at 48 and 54. This compound has existed in the Earth for 300 million years. The military knew what it could do in 1944. NASA confirmed it in 1946. 40 peer-reviewed studies across 3 decades repeated it in language anyone can read. Eric's grandfather knew it in a barn in 1920 without a single research paper to back him up. Hiroshi Tanaka proved it across 22 vehicles and 58,000 kilometers of commercial driving with nothing but a maintenance log and enough patience to let the data speak. And in all that time, not one dealership service advisor, not one had any financial reason to mention it to you. It was not buried because it failed. It was buried because it worked, and because an engine that runs for 500,000 miles on $40 of mineral cannot also generate $40,000 in repair revenue over its lifetime. Those two things cannot both be true at the same time. You are not a customer in this system. You are a recurring revenue event. If you are the kind of person who believes you deserve to make decisions based on accurate information, not on what is profitable for someone else to tell you, you already know what to do next. 100 grams, $2.40. The same search terms I gave you. This weekend. Leave your vehicle, make mileage, and whether you have a cold start, knock in the comments below. One word is enough. I read every one. I want to build a record across every make and model so the next person who finds this video sees results from someone driving the same thing they drive. Next week, I am going to show you a material that was standard in every American home before 1951. Not removed because it failed, not removed because it was dangerous. Removed because the replacement created a $4 billion annual market that still charges every homeowner in this country $300 a year for a problem that did not exist before 1952. The same pattern, different industry, same math. When you see it, this video will look like the introduction it was always meant to be. Harold Briggs is still driving that truck. 487,000 miles. Original engine, $40. He had no idea the first time he treated it that he was doing anything remarkable. He just knew something that most people were never told.